So 16, 17, and 18, again, we have some word problems that we're going to do. Based on sine and cosine functions, the population size of many animal species rise and fall over time. Suppose the population size can be modeled by the following function. P of t equals, this would be my starting population, 2,680, and then it's going to change by 1,280 times the cosine of 1.4t. In this equation, P of t represents the total population size, t is the time in years. So first of all, if I'm looking for the amplitude of P, again, my amplitude is that number, it's the absolute value of 1,280, so we'll still get 1,280. My period, again, is still 2 pi over b, so if I take 2 pi and I divide it by 1.4, I'm going to grab my calculator in order to find that, because they want us to round to the nearest hundredth. So for pi, you could use 3.14159, but I would recommend you just use the pi on your calculator. So 2 shift pi, so you see 2 pi divided by 1.4. Use the division instead of the fraction because you do want a decimal answer. And you end up with 4.4879. We're rounding to the nearest hundredth, so I would say 4.49 years when I round that off. My frequency of cycles per year, how many cycles per year am I going to get? I'm going to basically just flip my period upside down and do b over 2 pi. So I'm going to have 1.4 over 2 pi. And again, I would just use my calculator and do 1.4 divided by 2 shift pi. So the 2 pi shows up right under, or right behind the division. And so I get 0.2228, rounding to the nearest hundredth. I have 0.22 cycles a year. In other words, it takes a fifth of a year, or a fifth, does 1/5 of a cycle every year. It takes 5 years about to do one whole cycle then. So, amplitude, again, we get from the A value, period, 2 pi over b, frequency, b over 2 pi. (17) says, a person sitting on a Ferris wheel rises and falls as the wheel turns. Suppose that a person's height above the ground is described by the following function. So we have 18.8 plus 17.5 sine of 1.6t. In this equation, the height above ground in meters is in meters, and t is the time in minutes. So we want to find the maximum height above the ground. Well, this is my starting shift. I shifted up 18.8. My amplitude is 17.5. So if I take 18.8 and add my 17.5, I get 36.3. So 36.3 meters is going to be the maximum height that I am above the ground. Frequency, we are going to do b over 2 pi, and so my b value is 1.6, so I'm going to take 1.6 divided by 2 pi, 1.6 divided by 2 shift pi, gives me 0.2546, I'm rounding to the nearest hundredth, so 0.25 revolutions per minute is my frequency. The time for one complete revolution is asking for your period. The period is one complete cycle, right? So I'm going to say that I have 2 pi over b, so 2 pi over my 1.6. So 2 pi divided by 1.6 gives me 3.926, rounding that off to the nearest hundredth. 3.93 minutes is how long it would take to do one revolution on my Ferris wheel. Last one on this packet, number 18 here, says, The depth of the water in a bay varies throughout the day with the tide. Suppose we can model the depth of the water with the following function. Starts at 22, I'm going to do negative 7.5 times the sine of 51, or 0.51 t. So first of all, they want us to find here, what is the minimum depth of the water? So I'm starting at 22 feet, but I'm going to go down 7.5 because of my amplitude, right? My cycle goes up and down, up and down. So if I take 22 minus 7.5, 14.5 feet would be my minimum depth. My period, 2 pi over b, so 2 pi divided by 0.51. So 2 shift pi divided by 0.51 would give me 12.319. So I'm rounding to the nearest hundredth. 12.32 hours then is what I would round that off to. The number of tidal cycles per hour is asking for your frequency. How long does it take to do the cycles in cycles per hour? So I am going to take b over 2 pi, and so 0.51 divided by 2 pi, 0.51 divided by 2 shift pi gives me 0.0811, rounding to the nearest hundredth, 0.08 cycles per hour then is what I would have for my frequency.